So at this point, I have graded half of the imaginary quizzes, and I wish the grades were imaginary. They're bad, kids. What is I cubed? You are supposed to know that I squared is -1, I cubed is -I, and I to the fourth is 1. This was missed by a lot of kids. That's straight memorization. I cubed is -I. Compute I to the 42nd. The deal is you do some long division, you divide by 4, you keep the remainder. We enter 4 once, we subtract 0, bring down to 2. Can't happen. 4 can't enter 2, so we have a remainder of 2. So I to the 42nd is equivalent to I squared, which is -1. We shouldn't be missing these. Compute I squared I cubed. I squared I cubed is the same as I to the 5th, which is the same as I to the 1st, because 4 enters 5 one time with a remainder of 1. So this is just I. Compute I to the -7th. First thing is the rewrite. Rewrite that as 1 over I to the 7th. If I can write 1 over I to the 7th. Then, either in your head or long division, figure out what your remainder is. So it turns out that this is equivalent to 1 over I cubed. I cubed is -I. This is 1 over -I. I fixed that by multiplying the numerator and denominator by an I. So I will have 1 times I in the numerator, which is I. I will have -I squared in the denominator. I know that I squared is a -1, and a -1 times a -1 is just 1. So I over 1, I is my choice. 5 is finding absolute value of a complex number, and so many of you picked the choice that I knew you would pick, and it was wrong. This is the distance to the origin on the imaginary plane. I did a video where I explained this. This is the real axis, and this is the imaginary axis. So I go back 4, then I go up 3. Here's where the point is. This would be the distance to that point. Now in the video I kind of did a little Pythagorean theorem. I did the old a squared plus b squared is c squared. Then I showed you how to do it with just, what it was. So I'm going to take a -4 and I'm going to square it. I'm going to take a 3 and I'm going to square it, and that's going to be my hypotenuse, or my distance to the origin. That's 16, that's 9. 16 and 9 makes 25. The square root of 25 is 5. It was 5. I know there was an example just like that in IXL. 6 is the same concept. When you plot this thing, all you got to do is fall 6 units. So this distance is 6. That's the concept. That's what absolute value is. Absolute value is a concept of distance. That's what it is. It's what it's always been. It's what it always will be. All right, this one, a lot of kids mess this one up because it says simplify. Simplify. So the shortcut to this was to take your terms, a squared and b squared, because this is a and this is bi, take them and square them. So I would have a 6 squared plus a 10 squared, which is the root of 136, but it says simplify. That's what it says. So 136 is even. You should try dividing it by something that's even that you can take the square root of, like 4. All right? Turns out that 136 is 4 times 34. And the root of 4 is 2. Choice D. Simplify this one. I don't think this one went too bad. The real number is 4. And when I put those together, I get -28. I say that. I bet if I go back and look, half my student body missed it, because Lord help you can't add or subtract. I'm going to drop these parentheses. I'm going to distribute my negative, and negative times negative is positive. So I have 7 minus 8. Those are real terms. That's -1. And that was, well, it was almost enough to finish the problem. Then I have a positive 4i and a positive 6i. That's plus 10i. So choice C. Number 10, I'm going to have to FOIL. Jesus would FOIL. F.O.I.L. 7 times 5 is 35. 7 times a -2i is minus 14i. 3i times 5 plus 15i. Of course, I've done this for years and years. I know a lot of kids can't FOIL to save their life. I get it. But it's something that we can all do if we wanted to. 3i times a -2i is -6i squared. And again, I know that I squared is -1. So this last piece becomes a positive 6. This right here is going to make a -i, and then I'm going to have plus 6 because -6 times -1 is positive 6. So I'm looking for 41. I wrote minus there. 15 minus 14 plus I. Simple distributive property. Distribute the -i in. -5i plus 3i squared, and again I squared is -1. So -5i plus 3 times a -1 should be done. It's choice A. -3 minus 5i. Division ones. I'm going to multiply the numerator and denominator by the complex conjugate of -i, which is just I. I'm going to distribute. That's going to be 7i minus 4i squared, sitting over a -i squared. I squared again is -1. Always has been, always will be. This is going to be 7i, -1 times -4 plus 4. -i squared, -1 times negative is positive. And that's just that guy. And you put it in proper form. 13, we're going to have to do a little bit of the complex conjugate, and we're going to have to do the FOIL method. The complex conjugate of 5 minus 2i is 5 plus 2i. Up top, we have to FOIL. 3 times 5 is 15. 3 times 2i is plus 6i. 4i times 5 is 20i. 4i times 2i is plus 8i squared. Down low, all that matters is first and last. That's it. 5 times 5 is 25. -2i times positive 2i is -4i squared. And again, there's this guy. I squared is -1. So the bottom becomes 29 because this is really a 4. Up top, this 8i squared is actually -8. 15 minus 8 is 7. 6 and 20 makes 26. So you can kind of see right now that the answer is C. I hope you can. I'm trying to do this during my lunch break. I got 6 to go. This one threw kids off. Root 5 times root 5 is root 25, which is 5. When you multiply a radical by itself, you get the number inside, okay? So this is the first thing I'm doing. I have a -5 times 4, which is -20. I've got an I in there. Then I have root 5 times root 5, which is just 5. So that first thing I did becomes -100i. That eliminates B and D, right? Here's the next thing I'm going to do. I'm going to do -5i root 5 times 5i because I'm doing the distributive property. So -5 times 5 is -25. I times I is I squared root 5. I squared is -1. A negative times a negative is positive. 25 root 5 is my real piece. So I have 25 root 5 and I have -100i, choice C. Simplify the root of -64. This should not have been missed. It is the imaginary root of 64. I guess you picked it. Shame on you for not knowing what the root of 64 is. It's 8. It has always been 8. It will always be 8. That was an easy question. Simplify the root of -150. It is the imaginary root of 150, but again it says simplify. $1.50 is 6/4, kids. I times 6/25. So the root of 25 is 5. 5i root 6. 96. This one I know is in IXL. I did it in IXL. This is what might have thrown you off, the I out front. First off, we have an I out front. I know it's the imaginary root of 96. All right? There's an I out front. That's I squared. 96 is 6/16. I squared is -1, so negative. Square root of 16 is 4, root 6. Choice B. Complex conjugate, make that a plus. That's all you do. Complex conjugate changes the sign of the imaginary piece. This one was pretty ugly, I'm not gonna lie. The goal is to have a common denominator of 6. To turn this into a 6, I doubled the bottom, so I doubled the top. To turn this into a 6, I tripled the bottom, so I tripled the top. By the way, a negative times negative is positive. This guy had a denominator of 1, so I had to multiply the denominator by 6. I have to 6 the top. This guy had a denominator of 2. I had to triple the top. Now everything's going to be over 6. I'm just going to focus on like terms. I have 8 minus 9, which is -1, plus 15, which is 14. I have 4i plus 24i, which is 28, minus 9, which is plus 19i. So I break apart. 14 over 6 is 7/3, divisible by 2. The sum of -3 plus 2i and its complex conjugate. Its complex conjugate is -3 minus 2i. And I just add down -6, and there are no i's. Ta-da! That's how long it takes to do this quiz, if you know what you're doing. So get to that point. Please get to that point. I need you to get to that point. You need you to get to that point. We all do.